let x1, x2, x9 and y be an independent and identically distributed normal with mean mu and sigma square as the variance random variables. Define x bar as, this is the usual x bar we defined, as square as defined as the 1 upon 8, which is 1 upon n minus 1 kind of structure. If n equal to 9 here, so this is s square is defined to be the distribution of 3 by root 10 x bar minus y upon s is asked. So how we will deal this question? So we want to find the distribution of, say, this quantity. So we see that, say, x bar follows normal mu with sigma square by n, where n is given to be 9. So this is standard result. So what results we have used actually? X bar is what? X bar is the linear combination of x1, x2 dot dot x9. So if x1, x2, xn are normal distribution, then their linear combination is also a normal distribution. So mean, we can find that mean this will be, and the variance similarly we can find simply. So this will be the part. So I'm just writing this is 9. And say y follows normal mu sigma square. So x bar minus y will follow normal distribution because x bar and y are independent and they follows normal distribution individually. So mean will be 0, and what will be the variance? So variance will be, say variance of x bar minus y, that will be variance of x bar plus, and the covariance is 0, so variance of x bar is sigma square by 9, and this variance of y is sigma square, so that will be 10 by 9 sigma square. So this will be 10 upon sigma square. So this is the information we have up till now. So now I'm doing what? So I'm using this information. So x bar minus y minus 0 upon, so this is 10 by 9, so 10 sigma square by 9, the root of this will follows normal 0 1. So this is the CLT, central limit theorem, simple results. So this implies that 3 upon root of 10, say x bar minus y, this follows normal distribution with mean 0 and standard deviation as 1. So you can see that we have a little bit similar structure to what we have asked. So we need s here as well. So let us do what is s square. That s is, say, 8 summation xi minus x bar square. So I is running from 1 to n, and from the theory perspective we know that the result is, say, n minus 1. Here n is 9, so 9 minus 1, 8 s square upon sigma square will follow chi square and minus 1, which will be 8. So this is results. So think how it came, and if you want to know the theory, I have discussed this in lectures, in the theory lectures completely, how it came, why it is so. So this is coming to be this. So this I can say, so s square, a kind of, I'm writing a loose terminologies, say sigma square upon 8, this is chi square 8, this kinds of stuff. Why I'm writing, you will understand this. So of course this is loose terminology. I cannot directly say that if this is, if this following this distribution, so this s square will just simply this. So I need proper logical flow for this, but still this is true. So s will be following, maybe s will have the distribution which kind of this random variable. Of course we need here proper justification for the reason, but this is true. So s is following these kinds of stuff. So what I have now, so now I what I want to take, so 3 by root 10, so 3 by root 10, say x bar minus y upon s square, s that is equals to, say 3 upon root of 10, say x bar minus y, say upon this sigma. So I'm just dividing and multiplying by sigma. So this is equal. So we know that this random variable following what, normal 0 1 and this s by 8. So from here I can take that simply, that this I am saying that s by sigma following, say root of chi square 8 upon 8. So this is following root of chi square 8 upon 8, and in the numerator this is following normal 0 1. So clearly this is the definition of the T8 distribution. So when we defined this T8 distribution, so we defined this as 3 by root 10, say x bar by sigma, and this is following chi square 8 upon 8. Of course I'm writing this as a random variable, so this will be T8. So this is the by definition of T distribution. So this let's see which is the answer, T8. So this is the answer.